Hi, my name is Anshuman and I'm one of the co-founders at Scalar Academy. If you're a techie, chances are you would have heard about CAP theorem. Today we would talk about what C, A and P in CAP theorem stand for, why it works the way it does, and what does CAP theorem mean in the modern ecosystem. I was fortunate to see tech at scale at Facebook and was able to design products that served millions of queries per second and billions of users. I'm here to share a few of those learnings with you. If you like the content, please like the video and subscribe to the channel.
All right, so let's first look at why do we even need to learn CAP theorem. CAP theorem is one of the most basic principles of distributed storage. So if at all you think about building or working on distributed systems in the future, CAP theorem is a must-have, must-know. So that's why you need to learn CAP theorem. Now, before I get into explaining CAP theorem, and I would try to do that with using as simple example as possible, I want to give credit to Kaushik, whose blog I have borrowed a few ideas from. So thank you, Kaushik, for coming up with a very, very innovative example. So let's get to it, right? So to elaborate CAP theorem, I'll take example of a real world example of let's say you. Imagine I'm an entrepreneur. I'm looking for ideas and I feel, you know what, like people need reminders. Let's build a service that just stores reminders, right? Which is, I get this very premium number. Imagine I name my company as ABCD and I get this very premium number, which is 1234, 1234. People could just call me on 1234, 1234 and they can tell me what they want to remember. And then when they call me back, I tell them what they wanted to remember and then things work. It seems to me that this is a great idea. So what I do is I set up this line. I sit in the office. Imagine this is me. Forgive my drawing. Imagine I sit in the office. Every time somebody tells me, let's say I got a call from X and X says, hey, please remember that I have a flight tomorrow at 9 p.m. I say, great. Next time they call and they ask me, tell me what I wanted you to remember. And then I tell them, you know what, do you have a flight tomorrow at 9 p.m.? And then this seems great. I charge people very nominal amount of money to store this information and service takes off. Everybody needs this. There's a big market. Everybody starts using it. And then I start to hit the problem. And you'll notice most systems, they start to hit the problem when they hit scale. Then I realize that I'm getting a lot of calls and I'm not enough to address all of those calls myself. So then I start to think, and then I think, sure, let me get my wife also involved. So now this number actually has me and my wife, both of us sit with our diaries where the call gets routed to either one of us, whoever is free. And when I get a call, I just very quickly, if the person is asking me to take a reminder, I just take down that reminder, right? And when the person calls me back, I respond back with the reminder. Great. I have suddenly now doubled my capacity. If I was able to take 1,000 requests in a day before, now I can take 2,000 requests because I have my wife to help me as well. Very soon, I got my first unhappy customer. Mr. X calls me one day and says, hey, can you please remind me when is my flight? And I look through my diary and I realize I don't have an entry corresponding to Mr. X. And I tell Mr. X, hey, look, I don't have an entry corresponding to you. Mr. X seems very disappointed, very angry, and then disconnects the call. Now I start to think, what might have happened? Either Mr. X was delusional, or maybe there was a fault at my end. And then I see that there might have been a problem. It is possible when Mr. X wanted to store their reminder, they might have called my wife. And my wife would have stored this entry that, hey, X wants a reminder for a flight at 7 p.m. tomorrow. However, that entry is not with me because that call never came to me. However, when X wanted to understand when their flight was, they ended up calling me instead of my wife because they don't know. They only know this number, 1234, 1234. And I don't have that entry. And this is why X is very unhappy. This is what is called as consistency problem, data consistency problem, which is an end consumer might have stored some data with me, and when they ask me back, there is no guarantee that they will get the data back because it depends on where the request comes to. If the request comes to my wife, they'll get their data back. If the request comes to me, they'll not get the data back if my wife's diary has that entry. This is a big problem. If not solved, my company will die. So I start to think, and I come up with a solution. I say, hey, look, here is what we could do. When X calls me to say that please note down that I have a flight tomorrow at, imagine, 6 p.m. I'll note it down in my diary. I'll also tell my wife to note down this entry, which is also that tomorrow 6 p.m. flight. And only when both of us have written the entry in my diary, in their own diaries, then I return success. Then I tell Mr. X, I have noted down your entry. That way, there is guarantee that both of our diaries, my diary and my wife's diary, they'll have the exact same entries. Consistency of data. They'll have the exact same entries. And great, my consistency problem is solved. Now, when X calls any one of us, we can respond back with the right data points. Things were going great. One day, I again start to face a problem. One day, my wife calls in sick. She's not keeping well, so she's not in the office. What that means is that my wife, for the time being, is gone. For a day is gone. And at that very moment, another gentleman Y calls me and tells me to note down an entry. I say, okay, sure, what's your entry? And they tell me, you know what, I have a flight tomorrow at 3 p.m. I say, great, let me note it down. Let me, by the way, also go and tell my wife to note it down. Oh, by the way, my wife is not here. She can't note it down. And therefore, I'll have to tell Y that, hey, I can't note down your request. Your request actually has failed, which means for the entire day, I can't take in any new requests. That is a availability problem, which is my system is not available to take all kind of write requests. In the case of software systems, for example, like Facebook, you could think of Facebook saying that for an entire day or for an hour or for a few minutes, you can't make any new posts or you can't post any new photos on Facebook. That is an availability problem. So again, I'm very stressed. What do? I don't want my business to fail. So I think and I come up with another solution. I say, you know what? When my wife is not here, so I have my diary. And imagine my wife is not here. So I have written a bunch of entries. This new day comes. Whatever entries I get, Mr. X says to note down something, I'll note it down. When Mr. Y says to note down something, I'll note it down. And when my wife returns back, because I want both of our diaries to be identical, I tell her, look, you'll not take up any phone calls till you have noted down all of the additional entries that I made in the previous day. Or if she was gone for last 2 days, then in the previous 2 days. So you first note down all of the additional entries and then you start taking calls. And then my problem is solved. Now, because if X calls me and says that, please note down that I have a flight tomorrow at 8 p.m. Even if my wife is not in the office, I can still note down the entry and therefore I'm still available. Since my wife will come back and she will actually catch up with whatever new entries are there in my diaries before answering any phone call. So we're also consistent, which is great. Things are going super good. And then comes another problem. One day, me and my wife, we both have fight and we stop talking to each other. So imagine I get a phone call, X says, hey, look, please note down, I have a flight tomorrow at 9 p.m. I can't note it down because I'm not able to talk to my wife. And if I note it down, then and tell X that, hey, look, I have noted down your entry, then my system becomes inconsistent, right? Because my diary has now different entries, my wife has different entries, and she's still taking calls. So when this network partition happens where I'm not able to talk to my wife or other systems, then I have to make a choice. Do I want to stay consistent or do I want to stay available? If I want to stay consistent, then if Mr. X calls me and says, please note down the entry, I will have to say, sorry, I can't. My system is down. It's not accepting any new write requests. If I want to stay available, then I can take down the entry, but then I become inconsistent. So if I choose consistency, then I become unavailable. If I choose availability, then I become inconsistent. And that is exactly the CAPS theorem. CAPS theorem says that if you have consistency, if you have availability, and if you have partition tolerance, then at a time you can only guarantee 2 out of these. You can't promise all 3 at the same time, which means when this network partition happens, I would have to choose between consistency and availability. I can't have both. That's the CAP theorem. Now I have 2 bonuses to add here. Most systems that are available and partition tolerant, which is called AP, A for availability, P for partitioning, C for consistency, right? Most systems that are AP can still make sure that they become eventually consistent. What does that mean? That means eventually my and my wife's diary, they have same entries. How do I make sure of that? Whenever we start talking again, we can exchange notes. Or maybe just imagine that there's a clerk here that I've hired who just takes up all of the new entries in the last 1 hour, tells me what those entries were, so I take those down. Also, by the way, asks me what were the entries that I made in the last 1 hour, goes back to my wife and tells, here are the new entries that were made in the last 1 hour. So there might be periods in between that I was inconsistent, but eventually we become consistent. So that is eventually consistency. There is one more extension to CAP theorem that was done very recently, actually not very recently, about 10 years back, which is called as PACELC theorem. And what this theorem states is that, hey, look, when network partition happens, when my systems can't talk to each other, then sure, you have to choose between availability or consistency. You can't have both. However, there are going to be cases when my systems can talk to each other, which means there is no network partition, which is else. So else, I have to choose between latency or consistency. I can't have both. If you notice, when I made this decision that to stay consistent, I will make sure that on every single call, I will make sure my wife also notes down the entry, and only then I return success. Then I'm actually waiting for my wife to note down that entry. My wife could be doing something else at that time. My wife could be answering some other call. And in that case, the entire request might end up taking a lot of time. So the latency could become high because I want consistency. However, if I was willing to let go of consistency, which is I wanted to say that, hey, look, I'll just note it down, and maybe my wife could probably catch up later on, then latency could stay really low. So then you would actually have a balance between latency and consistency when there is no network partition. So that's what PACELC theorem is, which is just an extension to the CAP theorem, because CAP theorem does not talk about latency. I hope that made sense to you, and I hope that was helpful. This CAP theorem is one of the most basic and one of the most useful theorems you'll come across when designing distributed systems. I'll keep doing more videos like this. If you like this video, please like the current video and subscribe to the channel. Thank you. Thank you so much.
If you are new to tech and you have recently heard the term caching and don't know what it means, then this video is for you. I was fortunate to see scale at Facebook. I was fortunate to be part of teams that build products that scale to millions of queries per second and billions of users. I'm here to share some of those learnings with you. If you like the content, please like the video and subscribe to the channel.
All right, so I'll try to explain caching as simple examples as possible. By the way, there is a bonus problem at the end of this video, so please do stay till the end of the video to look at the solution of that. All right, so let's imagine that you want to make milk tea. One obvious ingredient of milk tea is milk itself. And milk I find in most grocery stores, department stores that are around me. So one obvious way whenever I'm making milk tea is that I go to the department store, fetch milk from here, and then make my milk tea. This to and fro process, by the way, ends up taking a lot of time. However, one thing which strikes me is, by the way, I can buy a refrigerator. I can buy a fridge which stays in my house only, where I can buy few milk cartons at a time and I can store it here. And when I'm making a milk tea now, then as long as there is some milk present in the fridge, I can use it from here. If there is no milk present in the fridge, then I go to the department store and I buy the next set of cartons of milk. So what have I done in the process? I could still have gotten milk from department store. It's the same milk. However, I created this temporary storage, which is close to me, which is much faster for me to be able to store those milk so that I can make my milk tea faster. Plus, then I have more motivation to make milk tea because I have it in my fridge. Very similarly, if you look at the design world, distributed systems world, you always have these systems that are looking for some or the other information, right? So machines talk to each other, they query for information. Imagine you load your Facebook profile page. That profile page would need to show your name, email ID, your friends, etc., etc. So for that, it would need a lot of information. So this machine would then ask for profile information for yours, which would be there in some other machine in the hard disk. And reading from hard disk is slow. If you would have noticed, when you transfer movies, etc., from your friend's laptop, those movies are written to your hard disk, and those hard disk writes are fairly slow. Very similarly, reading from the hard disk is also slow, especially if your data is lying somewhere you don't know where. So you'll have to search through the index to find where this profile information is and then fetch that data from there. However, if the same information was in RAM somehow, which is main memory, then accessing that would be faster. However, I mean, if we're talking about Facebook has so many people, so many profiles, all information cannot reside in RAM. It has to be in the hard disk, which is the same as me going to the department store every single time when I want to make milk tea. However, if I know that there are, let's say, certain profile pages that are fetched very often, that are more likely to be fetched than the other profile pages, then maybe I can create a fridge, a refrigerator, where I can store the information of these pages, so that when somebody asks for these pages, then I don't go to the departmental store, which is the hard disk in this case. Maybe I have that information in RAM or a faster memory access. I mean, let's not say RAM, some place where I can find that information faster than actually having to read from the hard disk of a different machine. That process is called caching. Caching is exactly what I did with my refrigerator to department store. It is exactly doing that to reduce the latency of fetching that information in some cases. A cache will never be as big as your total storage. There will always be cases when I run out of milk in my refrigerator or when the information is not present in this fast storage. And that process, by the way, this is caching. And when I find data in my cache, it's called a hit. When I do not find the data because it is not present, therefore I'll have to go to the departmental store or go and read from this hard disk. That is called miss. So whenever you find data in the cache, it's a hit. You don't find it, it's a miss. That is caching. And caching is something, by the way, you encounter on a day-to-day basis. For example, you might have noticed that when you load a website for the first time, it's usually slower. But when you refresh, it loads faster. Sometimes when your internet is not working, you keep refreshing after a while, and eventually the website loads. Your internet doesn't get faster. That's not the reason why it loads. It loads because once, let's say there was an image on the website. Once that image has loaded, that means your browser has now gotten that carton of milk. So it caches that in its own memory. On your browser, on Chrome, it gets cached. So next time when you load the same website with the same image, the browser doesn't go and fetch the entire image from the other website. It only checks if it was the same image. If it was the same image, then it fetches it from its local memory, which means I don't have to go over that slow internet to fetch that image. And therefore, by using caching, I have significantly reduced the latency of fetching that data. That is caching with your browser. Systems within also do caching in various forms. One simple question I have. If you haven't seen my cap theorem video, please go and see that, because this question is slightly based off that. Imagine you are building a very consistent system. You would want that if you're doing caching, then this cache data is exactly consistent and exactly the same as the data present in your hard disk for whatever entries it has. If you're building a consistent system and you're doing caching there when I ask you to update, how do you go about updating such a system? In the context of the departmental store and milk tea example, let's say that you want your milk tea to always use the latest milk that is present in the department store, or always use the milk that is present in the department store. How do you validate that the milk that you have in fridge as of now is exactly the same milk that is present in department store? How do you do that? There is something called as, actually, if you look at how you would do it, there are only two ways of doing it, right? One is when you tell me that, hey, here is new milk to restock your store with, or here is new data, right? Which is, let's say, and on my profile name, for some reason, my name changes. So whenever there is data pertaining to me that is being updated, it does not go directly to the hard disk. Imagine this is my hard disk or hard disk storage, and here is cache. Whenever this update operation comes, it goes through the cache. So first I check, is this entry present in the cache, which is my name, is my profile cached? If it is cached, then I first update the entry in the cache, and then I update the entry in the hard disk. And only then, when both of them have been updated, only then I return success. This is called write through cache. which means whenever new milk comes to the department store, it goes through me. It goes through my house. I do a verification and only then I let the milk pass. That is right through cache. Or the other way could be that if the database is aware of where my caching system is, whenever there is a profile update, the database tells cache to throw away whatever information I have regarding my profile because that is now out of date. And only once invalidation has been done, only this write has been done, invalidation has been done, only then you return success. Or in the context of, again, departmental stores as well as milk, let's say whenever my department stores gets a new kind of milk, they call me up and they say, hey, look, please throw away the milk that you have in your refrigerator. It is old now. We have a newer quality of milk. And that way I make sure I'm always cooking my milk tea with the newest quality of milk that I have in the market. That way I stay consistent. That was all for me for today. I hope, again, caching made sense to you. You understood why caching happens in systems. I'll keep doing more of these videos to help you with more concepts around distributed systems and data structures. If you like the video, please like this video and subscribe to the channel. Leave a comment if you want me to do a video on a topic that you find interesting. Thank you. Thank you so much.